5.2, number 80. This is very similar in kind to the problem we just did in 5.2, number 72, where we're going to interpret the integral as an area of a regular shape that we're familiar with. So we have here the integral -2 to 2 of the function root of 4 minus x squared dx. And we're supposed to find the answer to this. It says using area formulas. So find the answer. Area formulas means basic geometric formulas you're probably aware of or could easily reference. So let's think about this function root of 4 minus x squared. That is our integrand. So if I graph that, so 1, 2, 3, 1, 2, 1, 2, something like this. So let's see, if we represented y as the root of 4 minus x squared, if we square both sides, we'll get y squared equals 4 minus x squared, which will give us x squared plus y squared equals 4, which is a circle in standard form of radius 2 centered at 0, 0. So if we go ahead and plot that on this graph now, circle of radius 2 centered at 0, 0, it's something like this. All right, and now let's just think about what we're doing very quickly. We had the positive root of 4 minus x squared. The positive root of 4 minus x squared. So that means we're dealing with the upper part of the circle only. Even though this equation describes the entirety of the circle, because the function that we're talking about is simply the positive root of 4 minus x squared, we're dealing with the upper half of this circle. All right, and it looks like we're dealing with the integral from -2 to 2, so we want to find, right, there's our interval, -2 to 2. We should be finding this area, not the lower area. We're only concerned about the upper half of the circle because of the way the function was described in the integrand. Again, positive root of 4 minus x squared. So there's the area that this integral represents. Integral root 4 minus x squared from -2 to 2 is this red shaded area right here. But we know from regular formulae regarding circles that this area should be the same as pi r squared and then cut in half. But we know r is 2 here, right, as we just said, so that implies that the area here is going to be pi 2 squared on 2, which should be 2 pi. There's our answer.